All right, how about this scenario? If you've got a 5-meter tall hill, block on top of it going 3 meters per second, slides down this ramp at a 40-degree angle, coefficient of friction is 0.3. We want to know when it gets to the bottom of the hill, how fast is it going? So it's moving, and it has a height. So it's got two types of energy there. There's a ton of lost energy here, and here it's moving, so it's got kinetic energy. Here's our dividing line. Notice the dividing line always happens after the lost or gained energy. This stuff happened, and now you have this stuff. So kinetic energy plus the potential energy minus the loss equals the kinetic energy. Loss is just a fancy name, easy name for work. Work is force times distance. In this case, the force is friction. Force of friction is mu times the normal force. And this next step is the crucial one, because the normal force isn't equal to mg. And that's the whole point of this problem. Here's the picture. There's gravity. Here's the normal force. Normal force, remember, is equal to force of gravity in the y direction. So that would be force of gravity, cosine of theta is force of gravity y over force of gravity. So mg cos theta is equal to the normal force. Which means you have this, 1/2 mv squared plus mgh minus mu mg cos theta times d equals arg 1/2 mv squared plus mgh minus mu mg cos theta times d. If you're going to make a mistake, it almost always happens right here. You forget to put the d in. Equals 1/2 mv squared. Now notice nicely, mass drops out, which is nice mathematically, but even more cool physics. It says that the mass doesn't matter. It could be a 20-kilogram boulder, or it could be a 1-kilogram rock. It could be a slide, it could be a sled. Doesn't matter. You're going to go with the same speed at the bottom. So 1/2 3 squared plus 9.8 times 5 minus 0.3 times 9.8 times cos theta, cos of 40, times, the distance of the ramp, which I got to tell us, is 1/2 v squared. And it's true, it's a 5-meter long hill and a 40-degree angle, so we got to figure out the distance of the ramp. Distance would be, let's see, sine of 40 would be h over d, which is 5 over d. So the length of the hill is 5 divided by sine 40, 7.7 meters. So then we've got 1/2 3 squared plus 9.8 times 5 minus 0.3 9.8 cos 40 times 7.7 equals 1/2 v squared. And we solve. And we get 8.5 meters per second. The key parts, we have to account for all of the energy, what we have in our system and what we have out of our system. And the stuff that we have moving, we have to take out. We got to say it's somewhere else that's not available to us. This one's special because you've got this bonus normal force.